Good evening, children.
Good evening,
Good
ma'am.
evening, ma'am. Good evening, ma'am.
Good evening. I've shared my screen. Is it visible to all of you?
Yes, ma'am.
Yes, ma'am.
Yeah. So I had shared this image as homework for the weekend. How many of you have completed?
Ma'am, I completed, ma'am.
Okay. Navneet.
I didn't get this, ma'am.
Okay. I think I have to still include you in the broadcast list. I'm sorry about that. All right. We'll discuss the answers. I'll share the images on WhatsApp with you. Sahana, no, Sahasra, right? Shri Sahasra. I'll
Yes.
include your number on my in my broadcast list, so you will receive messages in future. So we'll discuss these answers, children, and I'll share the answer images on WhatsApp. So if you have not completed your homework, you can complete it by the next class. So the first one, find the value of 7.5, the whole square. So 7.5, the whole square, or 7.5 squared. Find the value of 7.5, the whole square, or 7.5 squared, which means 7.5 into 7.5, right? So what's the answer? What's the answer?
Ma'am, 56.25. Ma'am, can we note it?
56.25. 56.25.
Ma'am, can we note it? Or
Can
we
we?
have to note it?
No. You will not get time to write now because this was assignment. You
Okay.
should have completed it. That's what I told you. I'll share the images on WhatsApp so you can complete it later at home. Okay. So 7.5 squared is equal to 7.5 into 7.5, which is 56.25. Because 75 into 75 is 5625. And after the decimal point, we have one digit here. And here after the decimal point, one digit. So totally 1 plus 1, 2 digits. So in the product, you must place a decimal point so that you have 2 digits after it. One decimal place, one decimal place. So totally 2 decimal places. So the product also should have 2 decimal places. 2 decimal places. The square of 100 is
20.
Ma'am, 10,000.
10,000. The square of 100. The square of 100 is 10,000. The square of 100 meaning 100 squared. The square root of 100 is 10. The square root of 100 is 10. The square of 100. The square of 100 is 10,000. The square root of 100 is 10. The square of 100 is 100 into 100. 10,000. The value of square root of 25 minus square root of 36 is equal to, what's the answer?
Minus 1. Ma'am, minus 1.
Minus 1. Correct. Minus 1. Because square root of 25 is 5 into 5. Meaning square root of 25 can be written as square root of 5 into 5. Square root of 36 can be written as square root of 6 into 6. So from 2 5s, 1 5 out of the square root. From 2 6s, 1 6 out of the square root. So 5 minus 6 minus 1. Square root of 25 is 5. Square root of 36 is 6. So 5 minus 6 is minus 1. So the answer is minus 1. The square of 49 is?
Ma'am, 2,401.
Correct. The square of 49. the square of 49, meaning 49 squared is 49 into 49, which is 2401. The square root of 49 is?
Ma'am, 7.
7. The square root of 49, square root of 49 is 7. Express 12,100 as a product of its prime factors.
Ma'am, can I say?
Yeah.
Ma'am, 12,000. First, we need to do prime factorization.
Yeah, go ahead.
Yeah, ma'am, can I directly go to the prime factorization or can I?
Yes, I want just complete this. 12,100 can be written as
2 square into 5 square into 11 square, and then we need to do the square root of 12,100 is equal to.
That's the mistake. No. That's it. What is the question? Answer the question. If you're asked your name, just say your name and leave it there. You should not be saying I study in 8th grade, I go to this school. Answer the question. Yeah, express 12,100 as a product of its prime factors. That's all. You're not asked to find the square root of the given number. Just express it as a product of its prime factors. That's it. This is the answer. So we have expressed 12,000 as a product. See the multiplication sign. Product of its prime factors. So the prime factors in the factorization of 12,100 are 2, 5, and 11. These are the prime factors you see. 2, 5, and 11 are the prime factors involved in the factorization of 12,100. 2, 5, and 11 are the prime factors involved in the factorization of 12,100. So this is the answer. Yeah, you can write it as 2 squared. This is also fine. 2 squared into 5 squared into 11 squared is also good. So the question is express 12,100 as a product of its prime factors. The question is not find the square root of 12,100. So this is the answer. 12,100 is equal to 2 squared into 5 squared into 11 squared. So we have expressed 12,100 as a product, meaning multiplication sign you can see here, product of its prime factors 2, 5, and 11. Yeah.
Okay, ma'am.
Yeah, what's the answer with this one?
Ma'am?
Yeah.
Yes, ma'am. So we need to express it as x
I
square.
just want the final answer. I want the final answer. Just read the final answer from your book. I don't want any explanation.
I actually did it wrong. So the steps are a little bit different. So can I say the
fine.
steps?
All right, children. So see here. Xy cubed z to the power 4, the whole squared, is equal to xy cubed z to the power 4 into xy cubed z to the power 4. Correct? I'll explain this in two different ways. So the whole squared meaning multiply the base with itself, right? This is the base. Multiply that with itself. Xy cubed z to the power 4 whole squared, meaning multiply this with itself. So xy cubed z to the power 4 into xy cubed z to the power 4. Now by the law of exponents, when bases are same, so it's like x into x into y cubed into y cubed into z to the power 4 into z to the power 4. So by the law of exponents, when bases are same and its multiplication, we need to add the powers. So x to the power 1 plus 1 into y to the power 3 plus 3. Bases are same and its multiplication, add the powers. Add the powers. So x squared, y to the power 3 plus 3, 6, z to the power 4 plus 4, 8. This is the answer.
Yes, ma'am.
We can also work it like this. X y cubed z to the power 4 whole squared is equal to. So the power is applied to everything inside the bracket. So x is raised to the power 2. Y is already raised to the power 3. And this power 2 is also applicable. So multiply the powers into 3, into 2. Sorry. I'll just take a new slide. Yeah. So x y cubed z to the power 4. Okay, the whole squared is equal to x squared y to the power 3 into 2 z to the power 4 into 2. See, the power 2 is for x, y cubed and z to the power 4. The power 2 should be applied for every member inside the bracket. So you have x, you have y cubed, you have z to the power 4 inside the bracket. You need to apply 2 to every
Ma'am, we can't hear
member.
you.
Who's that? Who's that?
Oh, ma'am, we can't hear you.
All of you?
No, ma'am, I can hear you.
Ma'am, like that outline of you talking is coming, but audio is not coming.
Yes, ma'am.
Ma'am, can we rejoin?
Yeah, try that, all of you. Srijit, can you hear me?
Ma'am, I have a doubt.
You can hear me, is it, Danvin?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Sahasra and Harini, Sri Harini?
Yes, ma'am, I can hear you.
Then I think only these three boys. Okay.
Ma'am, doubt, ma'am.
Yes, Danvin?
Ma'am, is the power to the power 3 common for x and y, or is it not?
It's
It is
only
written.
yeah, okay. So x, when it is x, y
Ma'am,
cubed,
still we can't hear, ma'am.
Navneet, Anirudh and Avanish, is it? Just a minute, children. I'll just get back. I'll just check and get back. Yeah, Danvin, that was a good question. So in this expression x, y cubed, the power 3 is only for y. It's not for x. But when you have this expression x, y, the whole cubed, Then the power 3 is for y and x. Now, if you have a, b, c, d to the power 4, the power 4 is only for d. It's not for a, b, or c. Navneet, Anirudh and Avinish, can you hear me now? Yeah. Avinish, not Avinish, sorry, Danvin.
Yes, ma'am.
Yeah. Is it clear or shall I repeat?
Ma'am, I didn't understand.
Yeah. See, you asked me in an expression like this, is the power 3 only for y or even for x? That's your question, right?
Yes, ma'am.
Yeah, so I'll tell you, see, this is nothing but x into y to the power 3 into z to the power 4, the whole squared. All right.
Okay.
Now when it is the whole squared, the power 2 is applicable for every member inside the bracket. Okay.
Okay.
This power 2, which is outside, is applicable for every term, every member inside the bracket. See, if you have a plus b minus c the whole square, it's a different story. This is a different thing. When the connecting sign is plus or minus and there's a whole square here, it's a different thing. Now here it is multiplication. It's x into y to the power 3 into z to the power 4, the whole square. So here in this case, the power 2 is applicable for x, y to the power 3 and z to the power 4. But this power 3 is only for y. The power 4 is only for z.
Okay, ma'am.
Ma'am, now we can hear you, ma'am.
Okay, fine. Yeah, thank you. Yeah. So now, so here the power 3 is only for y. It's not for x or z. The power 4 is for z. It's not for y or x. All right, Danvin?
Yes, ma'am. Ma'am, but how can we identify whether it's alone or not? If it is given as xy to the power 3 or x,
Yeah,
x
if it
to
is
the power
xy to the power, if it's xy to the power 3, the power 3 is only for y. If it is xy and a bracket and then 3 here, then this 3 is for x and y.
Okay, ma'am.
Yeah. So again, by the law of exponents, the power 2 is applicable for every member here inside the bracket. So it is x to the power 2 into y to the power 3 into 2. See, y is already raised to the power 3. And this power 2 is also applicable for y. So multiply the powers. 3 into 2 into z to the power. Z is already raised to the power 4. Now this power 2 is also applicable for z. So into 2, multiply the powers. So this is x squared, y to the power 6, z to the power 8. That's what you see here. This is the first method I explained. We'll see it again. So see here, whole squared. So multiply this with itself. Now this means x into y cubed into z to the power 4 into x into y cubed into z to the power 4. So x, base are same and it's multiplication. Add the powers 1 plus 1 into y cubed, y cubed. Bases are same, y, add the powers, 3 plus 3. Z to the power 4, Z to the power 4, Z. Bases are same, add the powers, 4 plus 4. So 1 plus 1, 2x squared, 3 plus 3, 6, y to the power 6, and 4 plus 4, 8, z to the power 8. This is one method. The other method we understood is the power 2 is for every member inside the bracket. So take up x, raise it to the power 2. Now write y. Y is already raised to the power 3. Now this power 2 is also applicable for that. So multiply the powers z power 4 and apply this 2 also for z. So there's already this power 4. So multiply the powers 4 into 2. So it will be x squared, y to the power 6, z to the power 8. Same answer you will get. Yeah. What's the answer for this one? What's the square root of 36?
Ma'am, I have a doubt in this question only, ma'am.
Okay. What's the square root of 36? 6. See, square root of the question is square root of 36 into 8, a to the power 8 into b to the power 6 into c to the power 4. If you don't see any sign, it is multiplication. If you don't see any sign, it is multiplication. So it's 36 into a to the power 8 into b to the power 6 into c to the power 4. Now, to get rid of the square root symbol, to remove the square root symbol, am I audible to all of you?
Yes, ma'am.
Yes, ma'am.
Yeah.
Yes, ma'am.
Very good. Yeah. So in order to get rid of the square root symbol, okay, to get rid of the square root symbol, you will have to, if from equal factors, you'll have to bring half of them outside. So see here, the square root of 36 we know is 6. How many a's we have inside the square root or under the square root? How many a's? A into A into A into A into A 8 times, right? So if you want to get rid of the square root symbol, 4 a's you'll have to bring them out. That is A to the power 4. Just divide the power by 2. Just divide the power by 2. 8 by 2, A to the power 4. Then how many b's under the square root? 6 b's. We have b into b into b into b into b into b. 6 b's. So from 2 b's, 1 b out. From 2 b's, 1 b out. From 2 b's, 1 b out. So b to the power 3 comes out of the square root. So basically it is 6 by 2, 3. Then how many c's under the square root? C into C into C into C. 4 c's. So from 2 c's, 1 c out. From 2 c's, 1 c out. From 2 equal factors, we'll have to bring 1 out. So c squared. So this is the answer.
Ma'am, I have a doubt, ma'am.
1 second. Let me just do it again. Okay, so this is equal to square root of 36 can be written as 6 into 6. A to the power 8 can be written as A to the power 4 into A to the power 4. B to the power 6 can be written as B cubed into B cubed. And C to the power 4 can be written as C squared into C squared. So now from 2 6's, 1 6 out. We have 2 A to the power 4 under the square root. So one of that will come out. From these two B cubes, 1 B cubed out. From these two C squares, 1 C square out. So the answer is 6 A to the power 4 B cubed C squared. Yeah. Somebody.
How 36 becomes 6, ma'am? Because you always divided by 2. Like 8 divided by 2, like you did 4 and a square root of 36. Oh,
No. I have to answer that question. Children, don't talk amongst yourselves. Yeah. The square root of 36. Now, Anirudh, square root of A to the power 8, okay, means what? A into 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 A. All right. So from these two A's, one A out. 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 So A to the power 4 comes out. Now what is 36? What is the square root of 36? Square root of 36 is 2 into 2 into 3 into 3.
Yes, ma'am.
2 2s are 4, 4, 4 3s are 12, 12 3s are 36. So from these two 2s, 1 2 out. From 2 3s, 1 3 out. And 3 2s are 6.
Okay, ma'am.
Yeah. Is this understood?
Yes, ma'am.
From two equal factors, you should see, in order to get rid of the square root symbol, what is the rule to get rid of the square root symbol? You don't want the square root symbol. So what to do? From two equal factors, bring one out of the square root. So we have under the square root, we have 6 into 6. Write 1 6. Bring 1 6 out. So you're getting rid of the square root. Now we have a to the power 4. What is a to the power 8? A to the power 8 can be written as a to the power 4 into a to the power 4. Why? Because 4 plus 4 is 8. Because 4 plus 4 8. So from these two, 1 will come out, a to the power 4. Similarly, b to the power 6 can be written as b cubed into b cubed because 3 plus 3 is 6. So 1 b to the power 3 out. Similarly, c to the power 4 can be written as c squared into c squared. So 1 c squared out. Disable your mic, Sahasra. This is understood, children? Okay. So you can see the answer here. Okay. Find the value of square root of 121 by 169. What's the answer?
Ma'am, can I find? Can I tell?
Yeah.
Yes, ma'am. So, the square root 121 by 169 will go to the square root of 121 by the square root of 169. So, the answer is 11 by 13.
Correct. 11 by 13. Correct. So 121 can be written as 11 into 11. And 169 can be written as 13 into 13. 121 is 11 into 11. 169 is 13 into 13.
Yes, ma'am.
So
Yes,
from 2 11s, 1 11 out. From 2 13s, 1 13 out. So the answer is 11 by 13. Yeah.
Ma'am, can I tell the final answer?
Yeah.
I found it up to 2 decimal places. The answer is 39.25.
No, you're wrong. When the question is a mixed fraction, your answer also should be a mixed fraction. You shouldn't find it. You don't have to find. And see, you can validate your answer. What's your final answer? 39. Huh?
Yes, ma'am. 39.25.
No, see, the number itself is 15. 15 and something. So 15 it is. Okay, it's like more than 15, but less than 15. Sorry. The given number, the value of the given number is a little more than 15, but less than 16. Then how can the square root be 39 point something?
Oh,
it's like, yeah, it's like you're asked to find the square root of 50 and you're saying the answer is 129 point something. I'm just saying, how can it be? The number itself is 50. So the square root of 50 will be what? 7 sevens are 49. 8 eights are 64. So the answer should be 7 point something.
Okay, ma'am. Ma'am, 1 second, I'm doing.
No, we'll see the answer.
I did the division wrong. It's ma'am, 106 by 27. Yeah, I got that, but I did the division wrong.
Oh, okay, that's great. Okay, fine. Not great for doing the division incorrectly. Great because you got it till here. Good.
Yes.
All your children. So first convert this mixed fraction to an improper fraction. Okay, so that part you know. Convert this mixed fraction to an improper fraction. That's the first step. Then find the square root of the numerator, square root of the denominator. You can use a long division. Prime factorization method may be time consuming sometimes. Use a long division method. If nothing is mentioned, you can always use a long division method. Only if the question specifies. Only if the question specifies you to use the prime factorization method, you have to use that. If nothing is mentioned, you can use any method, but you should prefer to use a long division method. Choose the long division method. Choose a long division method if nothing is specified. So mixed fraction, convert that to an improper fraction, and then find the square root of the numerator and the denominator using the long division procedure. We get 106 and 27. So the square root of 11,236 by 729 is 106 by 27. Write that as a mixed fraction. Write that as a mixed fraction. Now we'll see how to find the square root. Listen carefully. Listen carefully, children. So you'll have to group the digits in twos from behind. Group in pairs from behind. So 3, 6, 1, 2, 1 stands alone. 1, 1s are 1, 0. Bring the next pair down. Double the quotient. 1 into 2 is 2.
2.
Yeah.
Dash.
Now, whatever you place here, you must place the same digit here.
6.
Now, 1 itself will be too much. 21 into 1. 21 into 1 is 21.
So 0.
That itself is too much. So it is 0.
Yes, ma'am.
So you'll have to place a 0 here and a 0 here. So 20 into 0 is 0.
So 12, 1, 2, 3, 6.
So 12 is the remainder.
Yes.
The next pair comes down.
Yes.
Double the quotient.
2,
Double the quotient. 10 into 2,
6.
20. 20. This is the last step. This is the last step. And the number ends with 6. So you must use 4 into 4, which can give you 6 in the end, 16. Or 6 into 6, 36, which gives you 6 in the end. So try 4 or 6. And you see that 6 works. 6 and 6. 206 into 6 is 1236. So here you can see this division is slightly different here. I'll tell you that also. See here. You can also do like this. All right. 1 ones are 1, 0 is a remainder. The next pair comes down, right? Double the quotient. Double the quotient 2. Now, whatever you place here, you must place the same thing here. So 0, 0. Place a 0 and you can bring the next pair down. Place a 0 here and a 0 here. So it's like what? 20 into 0 is 0 and you'll get the same thing down, right? You'll get the 12 down. So instead of doing that, what you can also do is after placing the 0, 0 here and here, bring the next pair down. Bring the next pair down. And now you'll have to place a digit here and place the same digit here. You can continue the same step. If you are not listening carefully, listen, I'll repeat. 1, 1s are 1. 0 is a remainder. 12 comes down, double the quotient. Whatever digit you place here, you must place the same thing here. So 20 into 0 is 0, right? Don't write that here because anyways, if you put a 0, you will get the same thing, 12 down. Instead, bring the next pair down and continue the same step. Place a digit here, place the same digit here. So 206 into 6 is 1236 and the remainder is 0. Yeah, what's the answer for this one? So you're able to divide the number by 2 times, 3 2 times, and then 17 2 times. So 10,404. Am I audible to all of you?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
All right, very good.
Yes, ma'am.
Yeah, good. So
Okay.
you see that 10,404 is 2 into 2 into 3 into 3 into 17 into 17. I've told you, repeat the step, write the step again and take square root on both the sides. Repeat the step, write the step once again and take square root on both the sides. That's the next step. Now, this will come down as it is. Okay. On the other side, we'll have to get rid of the square root symbol. We'll have to get rid of the square root symbol. So what we do, from two equal factors, we bring one out. From two equal factors, we bring one out. From two equal factors, we bring one out. And 2 into 3 into 17 is 102. So the square root of 10,404 is 102. See, I've asked you to memorize. I've given you the squares of natural numbers till 100. Memorize at least till 50. So when you see 289, when you see this number 289, you will not think for even a second. As soon as you see 289, you will immediately write 17 17s or 17 ones are. Because 17 is a prime number. 17 is a prime number. Now this 289 is not divisible by 2, 3, 5, 7, 11. 289 is not divisible by 2. It's not divisible by 3. It's not divisible by 5. It's not divisible by 7. Not divisible by 11, 13. You'll have to hit 17 straight away. See, that's why, I always follow this order. Listen to this carefully so that you don't have to go back. See now, 10,404. Listen to this carefully. I'll always start with 2. Always start with 2. Is this divisible by 2? Yes, it is divisible by 2. Then divide by 2. Suppose it's also divisible by 3. Don't use 3 first. See, you can divide using prime factors in any order. You will get the same correct answer. But there's an advantage when you use the prime factors in order. There's an advantage. I'll tell you what that advantage is. Now 10,404, it's divisible by 2. You know the prime factors, right? 2, 3, 5, 7, 11, 13, 17. It goes on like this. So you start with 2. Is it divisible by 2? Yes, it is. So then divide. If it is not divisible by 2, then check 3. So in this, see here, when it's not divisible by 2, the number will never be divisible by 2. So don't check 2 again. This number, if it is not divisible by 2, at any stage below, it will not be divisible by 2. At any stage below, it will not be divisible by 2. So you don't have to check that again. Now it's divisible by 2, right? So how many times? 5, 2, 0, 2 times. Now again, come from 2 itself. See now actually what 5 plus 2, 7, 7 plus 2, 9. It's divisible by 3. Don't jump to 3. As long as it is divisible by 2, keep dividing by 2. Once it's not divisible by 2, then you leave that and check the next number, next prime number. See, now this 5202 is divisible by 3. 5 plus 2, 7, 7 plus 2, 9. Don't use 3 now. Keep dividing by 2 as long as the number is divisible by 2. So it's divisible by 2. 2601 times. Now it's not divisible by 2. 2601 is not divisible by 2. Then further down also, no number will be divisible by 2. You need not check 2 again. So now leave 2. Check if it's divisible by 3.
Yes, ma'am.
Now further down, the numbers you get will not be divisible by 2. You don't have to check that again. So this is gone. 2 is done. Now see if it's divisible by 3. 2 plus 6, 8. 8 plus 1, 9. Yeah, it is divisible by 3. Then divide by 3. So 3, 867 times. Again, you don't have to check for 2. It won't be divisible by 2. 2 is done. In this factorization, you will not get 2 again. So it's, see if it's divisible by 3. 8 plus 6, 14. 14 plus 7, 21. Yeah, it is divisible because the sum of the digits is 21 and 21 is divisible by 3. So this number is divisible by 3. Test of divisibility. 3, 289 times.
Yes, ma'am. 17.
So now again you'll have to check if it's divisible by 3. Test of divisibility. 2 plus 8, 10. 10 plus 9, 19. No, 19 is not divisible by 3. So this number 289 is also not divisible by 3. 2 plus 8, 10. 10 plus 9, 19. The sum of the digits is 19. 19 is not divisible by 3. So the number 289 is also not divisible by 3. Not divisible by 3. 5, no, not divisible. 7, divide and check. 289 and 7. 7 4s are 28. 7 1s are 7. 2 is the remainder. No, it's not divisible. It's not divisible by 7. So 7 is also gone. 7 gone. Then 11. So you should divide. If you know the test of divisibility for 11, you can use it. Otherwise, you divide. You can do this faster. 289 and 11. 11 2s are 22. 6 is the remainder. 9 comes down. No, 11 6 are 66. No, it's not divisible. So this is also not. The number is not divisible by 11. Then 13. It's not divisible. So you'll have to do all this. But if you know that 17 into 17 is 289, if you have memorized, I told you at least minimum till 50. You should know 50 square up to 50 square. 50 square is 2,500. I'm not saying don't go beyond that. Learn at least till there. So if you didn't know that 17 into 17 is 289, then you have to do all this. Okay, so you'll have to check with 5, 7, 11, 13, and then you'll reach 17. You should keep doing. You should not give up. You should not be like, I tried till 11, it was not divisible, so I left the sum. No, no. That's why it's important. No, see, sometimes I'll tell you, see, what is 43 into 43? 43 into 43 is 1849. Now, if you get 1849, if you have 1849, it's divisible by 43. So you'll try to divide by 7, 11, 13, 17, 19, 23, 29. It won't be divisible because 43 is a prime number. But if you know that 43 into 43 is 1849, you can use it directly. 43 times 43 ones are finished. (1849), supposing you have to find the square root of 1849 using the prime factorization method. The question is find the square root of 1849 using the prime factorization method. So you'll try to divide by 2, not possible. 3, not possible. 5, not possible. 7, not possible. 11, not possible. 13, 17, then you become tired because there are other questions to answer. No, you cannot sit with this sum. So you'll try 19, then 23, and then you'll give up. No, then we'll think that the question is wrong. Not able to divide, the question is wrong. You might think so and just give up. But actually not, because 43 into 43 is 1849 and 43 is a prime number. 43 is a prime number. So you have to hit 43 straight away. No number below that can divide 1849. No prime number below 43 can divide 1849. So it is 43 times and 43 ones are. So it becomes important to memorize till 50 squared. It's important to memorize the squares of the natural numbers till 50. If you know till 100, very good. So what I'm trying to say is 289 is 17 17s are and 17 ones. So see this number. So this number is not divisible by 2, it's not divisible by 3, it's not divisible by 5, it's not divisible by 7, it's not divisible by 11. So you should go on. You must go on. Should not give up. There can be numbers like that. This number is not divisible by 2, the prime number 2, 3, 5, 7, 11. It's divisible by 13. So 13, 2197 times. Again 30. See, mostly, not mostly, when you're trying to find the square root by the prime factorization method, every prime factor will happen at least 2 times. 2 times, 4 times, 6 times, even number of times you will get. So when you divide by 13, you get 2197. Use 13 again. It should be divisible. This number will be divisible by 13 because every prime factor will happen at least 2 times. At least 2 times. If not 2, then 4 times, even number of times. Because this one is a perfect square. When the question is like this, find the square root of 28,561 using prime factorization method. That means the number is a perfect square. Otherwise, they'll not ask you to find the square root using the prime factorization method. If you're asked to find the square root of a number by the prime factorization method, then the number is a perfect square. If you're asked to find the square root of any number by the prime factorization method, it's understood that the number is a perfect square. So every prime factor will happen even number of times, 2 times or 4 times or 6 times. So if you use 13 once, use it again, it will be divisible. Then you get 169. So see, if you know 13 into 13 is 169, you will continue with 13. 13 13s are 13 ones. So 28,561 is 13 into 13 into 13 into 13. Take square root on both the sides. Take square root on both the sides. So from 2 13s, 113 out. From 2 13s, 113 out. So 13 into 13 is 169. So the square root of 28,561 is 169. Were these questions also given as homework? Because I have many more in the presentation. Was this a part of the homework?
Yes, till 13 questions, ma'am. 13 questions, ma'am.
13 questions. Okay. Now, we'll take this as a classwork because like I think other than Navneet, nobody's completed the homework, right? So we'll take this as today's classwork. Start working, children. Find the square root of all these numbers by the prime factorization method and the long division method. Start working. I'll come back in 10 minutes. You should have finished A and B, at least A and B. I'll come back in 10 minutes. You should have finished at least A and B. Yeah, start working. Write today's date. The name of the chapter, squares and square roots. Squares and square roots. Write the date. I think it's 25th. Check. 25th? Oh, today's 24th. I'm sorry. Today's 24th. Yeah, start working. Yeah, Srijit. What's the square root of the first number? 4,356.
Ma'am,
Square root of the first number, 4,356.
ma'am, I was mistakenly I went left the class, ma'am. Now only I came, ma'am.
Okay, who's completed the first one?
I was noting the questions, ma'am. So,
Ma'am,
66. Ma'am, 66.
60?
66.
66. Very good. Check your steps. And what about the prime factors of 4,356?
Ma'am, 2 into 2 into 3 into 3 into 11. Yes, ma'am. Ma'am, same, ma'am. Ma'am, 11 square, no, ma'am. 11 square only, ma'am.
Yeah. Check your answer. Harini, got this?
Yes,
Shri? Okay. You can see here I've used 2 and again divided by 2. Then this number is not divisible by 2. So then the next prime 3, again it's divisible by 3. Now this number 363, sorry, we get after dividing it by 3 2 times, you get 121. And 121 is not divisible by 3, not divisible by 5, not divisible by 7. So you see that it's divisible by 11. 11 11s are and 11 ones are. Yeah, what's the answer for this one? How do you express 2304 as a product of its prime factors?
Ma'am, we didn't still complete it.
Okay, fine.
Ma'am, can I just say the square root of this 2304?
Yeah, you have to find the square root only.
Ma'am, yes, we found it, ma'am. Yes, ma'am, in long division. 48. 48.
yes, ma'am, 48.
48. How do you express this number as a product of its prime factors?
Ma'am, can I tell?
Yeah.
2 into 2 into 3 into 3 into 2 into 2 into 2 into 2 into 2 into 2.
Very good. Okay. So it's 2 squared into 2 squared into 2 squared into 2 squared into 3 squared. Let's
Yes, ma'am.
check. Yeah, you're right. Please check your steps. I'll show you the next number, 39204. The next number is 39204. Please check this answer and then go to the next one. Shri Sahasra and Srijit must share the pictures of your classwork on WhatsApp with me. Okay?
Okay, ma'am.
Yeah. After the class. After the class, finish your dinner and share the pictures of your classwork. Whatever you've written in today's class, no, take pictures and put it on WhatsApp for me.
Okay, ma'am.
This is the next number, 39,204. Yeah, completed this one.
You're right. Ma'am, long division done, ma'am.
Okay, what's the square root of this number?
Ma'am, 198.
198.
Yes, ma'am.
Correct. Yeah, complete the other method also. completed working this one using the prime factorization method?
No, ma'am.
Okay. Finish it and let me know, children. Shri Harini?
Ma'am, I've done it, ma'am.
You finished this?
Yes,
Yeah,
ma'am.
sir. Okay, tell me, Sahasra.
It's 198, ma'am.
Yeah, correct. Have you completed the other method, prime factorization method?
Yes, ma'am.
Yeah. How do you express this number as a product of its prime factors?
2 into 2 into 3 into 3 into 3 into 3 into 11 into 11.
All right, let's check. Very good. Very good. Very nice. Correct. Yeah, please check your steps in detail now, all of you.
Ma'am, can you show the D sum? Finished, ma'am.
Yeah,
D.
sure. Yeah,
Finished,
yeah.
ma'am.
Very good. Yeah, this is the next one. Yeah, let me know, children. Once done, let me know. I'm right here. I'll just turn off my camera. I'm right here.
Ma'am.
Yes. Yeah,
Ma'am,
tell me.
can you show the previous page, ma'am? I want to check the long division.
Okay. Done, Shrijit?
Yes, ma'am.
All right.
Ma'am, the root of 3 369, 189. 189. Yes, ma'am. Sorry. Quotient term. 189, ma'am. 189.
Okay. What about the factorization?
Going to
3,
do, ma'am.
5.
We are going to do, ma'am.
Oh, okay. Harini, please participate. I called out earlier. Have you finished this one, Harini?
No, ma'am.
I want you to, yeah, I want you to tell me the factorization of 3, 5, 7, 2, 1.
Yes, ma'am.
Yeah. Yeah, Harini, tell me the factorization of 35,721 is?
Ma'am, doing it,
Who's finished this one?
Ma'am, can I tell the prime factors?
Yeah, tell me.
Ma'am, 3, 3 raised to the power 4 into 21 raised to the power 2.
21 is not a prime number.
Oh my God, sorry, sir.
See, I think because you got 441 and you know that 21 into 21 is 441, you've used that, correct?
Yeah, yes, ma'am, yeah.
No. It's 21 is not a prime number.
Yeah, ma'am, I forgot that, my bad, sorry. But actually, the number.
Yeah, tell me.
Ma'am, the answer is 3 square into 3 square into 3 square into 7 square.
Correct. 3 square into 3 square into 3 square into 7 square. Correct. So this is the factorization of prime factorization of 3 by 7 to 1. So what's the square root of the number? 3 into 3 into 3 into 7, which is 189. Very good, Sahasra. Very good. Navneet, you were right. But since it is prime factorization method, you are expected to use only prime factors.
Oh, yes, ma'am.
21
Okay.
is, yeah, it's a composite number, 21. Yeah. All of you check your answer. Check your answer, all of you.
Ma'am,
Yeah.
I got the answer.
So the next one, E.
Yes, ma'am.
Oh, that's
5
nice.
square into 5 square into 3 square into 3 square.
Hmm. So the square root is correct.
225.
225. Very good. Did you finish the long division method also?
No,
No,
ma'am.
right? Yeah. Finish that. Yeah. I'll present the answer again. Finish it.
Ma'am, I've done the long division also.
Yeah, read out from your book, Sahasra.
50625, 2 and 2 on the top, then 4, then 106, then 32.
What should we write beside 106 here?
4 now. And 6 and 2.
What's the remainder?
Can I say?
5.
Ma'am,
What's the remainder?
22.
6, yeah. Okay, then
Then
25
40,
comes down. Yeah. What is
44.
the number you'll be placing here?
44.
44. Very good.
And then you add 5.
Very good.
Then 2, 2, 2, 5.
Very good.
ma'am, can I say the prime factorization?
I think I already got it from Sahasra, but anyways, you can say. Yeah.
Yes, ma'am. 3 square into 3 square into 5 square into 5 square.
5 square into 5 square.
And
Correct.
then square and then the square root thing. And yeah, yes, ma'am, same. 225. Yeah, ma'am.
Very good. Very good, Navneet. All of you must have got it right.
Yes, ma'am. Yes, ma'am.
Very good.
Yes, ma'am.
All right, children. Okay.
Ma'am, 1 minute, ma'am. I'm writing, ma'am.
Okay. Yeah. Yeah.
Finished, ma'am.
Yeah. Yeah. This is your next question. Solve for x if x square is equal to 3,379.0969. So let me just tell you this, children. See, supposing you have this equation, a square is equal to 49. Then a is equal to the square root of 49. A is equal to 7. This is how we solve. Now I'll ask you, tell me how will you continue this? If a square is 100, what will be the next step? A is equal to?
A is equal to root of 100 and A is equal to 10.
Square root of 100. A is equal to 10. Okay,
And
one more.
similarly,
A square is equal to, supposing I say 169. A is equal to?
equal to root 169, A is equal to 13.
Square root of 169, A is equal to 13. Because 13 into 13 is 169. Okay. Supposing we have x squared or say y squared. Y squared is equal to 729. So y is equal to?
Y is equal to root 729. Root 729.
Square root of 729. Y is equal to?
Ma'am, 27.
27. Very good. 27. Okay. So in the same way here, x squared is equal to 3379.0969. So x is equal to the square root of 3379.0969. Now you can find the square root using the long division method.
Yes, ma'am.
Long division. Yeah. Find the square root using the long division method, and you know whatever answer you get here is the value for x. Yeah, do it. Write down the question. Yeah, well, just finish it and let me know.
Ma'am,
Yeah, Navneet?
ma'am, the answer is 58.09.
58.09.
Yes, ma'am.
Oh. 58 point. 58 point the integral part of the answer is right. The decimal part, just check. Let me also check with my calculator now. 3379.0969. Yeah. What you just announced is wrong. Check. Did you get remainder 0, Navneet, and others who gave that answer?
Yeah, ma'am, they copied me.
No. See, no. Did you get 0 remainder?
No, ma'am, not zero remainder.
That's it.
That answer is wrong. Ma'am, now I got it, ma'am. I got my mistake. I'll do it. Instead of putting 1, I put 0.
Oh, okay. Yeah, check and let me know. Correct it and let me know.
Mom, I said 58.13.
Perfect.
Ma'am, same. 58.13. Oh, yes, ma'am, same, ma'am.
58.13.
Ma'am, 58.13, yes, ma'am.
Perfect. Correct. Yeah, Dhanvan, read from your book. Help me complete this. Yeah. 6. Oh, not 6.
No, ma'am, 5 into 5.
5 into 5. Yeah.
25.
25.
Then it should be
Remainder?
8.
8. What comes down?
79.
79 comes down. Then what is the number that should be placed here?
Double the quotient, so 10.
10.
After 10, 8.
8. So
Which is 864.
864, is it?
Yes, ma'am. Remainder is 15.
15.
Double the quotient, so 116.
Okay.
Then bring down 0.09.
Not 0.09, 09. And
09.
Since you're bringing that pair, which is after the decimal point, place a decimal point in the quotient.
Okay.
Yeah.
Then into 1. 116.
Correct. 1161 into 1 is 1161.
1161.
Correct.
Remainder is 15.
15. Okay. 15. What's the remainder?
1 minute, ma'am. I'll check.
Can I say, ma'am,
34.
348.
Yeah.
Or 348. Yes, ma'am.
348. Okay.
Then bring down 69.
Mm.
So that double the quotient, so 1162.
1,162. Okay.
In 1000. Ma'am, then into 3.
3.
11623 into 3, which is 34869. So 0 is the remainder.
Correct. Very good. Navneet and others who have completed it correctly. So the value of x, what's the value of x? What is the value of x?
58.13.
58.13. The value of x is 58.13. Very good. So this one you'll have to present your answer in steps. X square is equal to 3379.0969 is given. So this means x is equal to the square root of the given number. Find the square root of the number using the long division procedure. And here you have the value for x. X is equal to 58.13. And next one. Yeah, work this. Find the least square number exactly divisible by 10, 15, 24, and 50. All of you find the LCM of 10, 15, 24, and 50. Find the LCM. I explained this question in the last class. We have least meaning smallest. Least meaning smallest.
120. Ma'am, 120 is LCM.
No, 120.
Oh,
120
no,
is not.
sorry, 50.
120 is not divisible by 50. 120 is not
Yes,
the
ma'am.
LCM. Okay, find the least meaning, find the smallest. Find the smallest square number. So we'll first find the smallest number. We'll first find the smallest number exactly divisible by these four numbers. So the smallest number exactly divisible by these numbers will be the LCM of these numbers. Then we'll convert that number to a square number. We have two conditions here. It should be the smallest number and it should also be the smallest square number. So we'll first find the smallest number, which is the LCM of these four numbers. And then with that LCM, with that smallest number, we'll convert that to a square number. So all of you first find the LCM of these four numbers.
Ma'am, 600 is the LCM.
600.
Yes, ma'am. Answer as here shown in the slide.
Did you get these prime factors?
Yes, ma'am. Yes, ma'am. Yeah. 2, 2. Yes, ma'am. The same only. Yeah.
Yeah, I got only 1 3.
Yeah, only 1, 3. Correct.
Yes, ma'am.
Only 1, 3. See here. 2 squared into 2 into 3 into 5 squared. All right. So first find the LCM of the four numbers, which is I haven't written the product here, which is 600. 2 squared into 2 into 3 into 5 squared. Now, 600 is not a square number because see here, every prime factor in 600 does not occur in pairs. You can see 2 and 3, they don't occur in pairs. If a number is a perfect square, then the prime factors involved will occur in pairs. If a number is a perfect square, then the prime factors involved in the number will occur in pairs. But you see here, 600 is the LCM of these four numbers. Now, how can we say that 600 is not a perfect square? Because see the prime factors in the factorization of 600, 2 to the power 2, 2, 3, and 5 squared. So you can see that this prime factor 2 and 3, they don't occur in pairs. There's only 1, 2, and 1, 3. So how do you make this number a square number? You need one more 2 and you need one more 3, right? Because it should be 2 squared and 3 squared. There's only 1, 2, and 1, 3. So this 2 needs another 2 so that it becomes 2 squared. And this 3 needs another 3 so that it becomes 3 squared. So you need to multiply 600 with 6. How 6? Because 2 into 3 is 6. So this is how you present the answer. So the smallest number exactly divisible by these four numbers is 2 squared into 2 into 3 into 5 squared. This is the smallest number. The smallest square number exactly divisible by these four numbers will be, write all these prime factors, here, all these prime factors, and multiply them with 1, 2, and 1, 3. So now this 2 into 2 becomes 2 squared, 3 into 3 becomes 3 squared. See the next step? 2 squared, 2 into 2, 2 squared, 3 into 3, 3 squared, 5 squared. Now you see that every prime factor occurs in pairs. Now find this product. It is 3600. So now 3600 is a perfect square. And we know that the square root of 3600 is 60. 3600 is a perfect square. We know that the square root of this number is 6. So understand two things. 600 is the smallest number. Is the smallest number that divides, that is exactly divisible by these four numbers. 600 is the smallest number that's exactly divisible by these four numbers. 3600 is the smallest square number exactly divisible by these four numbers. The LCM 600 is the smallest number exactly divisible by these four numbers, 10, 15, 24, and 50. 3600 is the smallest square number exactly divisible by 10, 15, 24, and 50. So the difference is 600 is not a perfect square. 3600 is a perfect square. This is the smallest number, but this is the smallest square number exactly divisible by the given four numbers. So this is the procedure for this question. Find the LCM using the factorization method, the prime factorization method. You don't have to find the product like 600. It's okay. You can write it, or even if you don't find the product, it's fine. Because the question is not to find the LCM. If the question is find the LCM of the four numbers, yes, then you have to find the product. The question is not to find the LCM, right? To answer the question, we have to go through the LCM. To answer this question, we have to go through the LCM. We'll have to find the LCM, but the question is not to find the LCM. So it's okay if you don't multiply this. All right. So find the LCM using the prime factorization method. And then you have one more step to find the square number, the smallest square number. And what is that step? Identify the primes that don't occur in pairs. Identify the primes that don't occur in pairs. So see here, 2 and 3. They don't occur in pairs. So you want 1 more 2, 1 more 3. So multiply by that 2 and 3. So now write the other prime. See, you can see this here. You can see this 5 square here. You can see these two also here. Write all of them and multiply that with 2 and 3. So now 2 into 2 is 2 squared. 3 into 3 is 3 squared. Find this product, 3600, and that's the required number. Yeah, please complete this.
Finished, ma'am. Finished, ma'am. Done, ma'am. Done, ma'am. Done, ma'am.
No, see, when I'm talking, you should be listening to me. You shouldn't be writing when I'm talking. Why are you all doing that?
Ma'am, we did it before itself, ma'am. Yeah, we did it before. We are just telling now. Okay. Ma'am, is class till 9 or 9:15?
9:15.
Okay, ma'am. Okay, ma'am.
Yeah. Yeah, this is the next question. What is the least number by which 6468 is to be multiplied to make it a perfect square? So let's understand the question first. The given number is not a perfect square. That's given. So what is the least number by which it should be multiplied so that the resultant number is a perfect square? Now, for example, 50 is not a perfect square. 50 is not a perfect square. Now, 2 is the smallest number by which 50 is to be multiplied so that the resultant number, the product 100, is a perfect square. 100 is a perfect square. "50 is not a perfect square." Now, if the question is what is the smallest number that is to be multiplied to 50 to make it a perfect square, the smallest number is 2. See, the smallest number can be 43. The smallest number need not be a very small number. It can be any number, but that should be the smallest number. The smallest number can be greater than 100 also. Smallest number does not mean a number of very small value like 2, 3, 5, not like that. It can be a large number, but that should be the smallest number. There should be no number smaller than that. So again, coming back to the same example, 50 is not a perfect square. So what is the least number by which 50 is to be multiplied so that it becomes a perfect square? The answer is 2. 50 into 2 is 100 and 100 is a perfect square. Another example, 12. 12 is not a perfect square. What is the least number by which it should be multiplied to make it a perfect square? 3. Because 12 threes are 36 and 36 is a perfect square. Getting it? Getting the question, children? Following the question? Am I audible to all of you?
Yes, ma'am. We understood. Yes, ma'am.
All right. So what is the procedure? How do you find the smallest number by which 6468 is to be multiplied to make the perfect square? So find the factorization, the prime factorization of the number 6468. So 6468 can be expressed as 2 squared into 3 into 7 squared into 11. You see that the factors 3 and 11 don't occur in pairs. So 3 into 11 is 33, and 33 is the smallest number that is to be multiplied to make 6468 a perfect square. Write down. Please write the question and take the answer. Done writing, children?
Done, yes, done, ma'am. Done, ma'am. Ma'am, 1 minute, ma'am.
Okay.
Ma'am,
Yeah.
ma'am, why we are taking 3 and 11, ma'am?
Yeah, if the number has to be a perfect square, every prime factor in the number should occur in pairs. If a number has to be a perfect square,
Okay.
every prime factor in the number must occur in pairs. Now,
Okay,
this number is not a perfect square because the primes 3 and 11, they don't occur in pairs.
Okay, ma'am.
So the smallest number to be multiplied to make it a perfect square will be, you need one more 3 to make it 3 square. You need one more 11 to make it 11 square.
Yes,
So the smallest number will be, you need one more 3 and one more 11. So 3 into 11, 33 is the smallest number.
Okay, okay.
Yeah, this is the
Ma'am,
next
can you
question.
show it once, ma'am?
Yeah.
Ma'am, you can go to the next question.
Done, Srijit?
Ma'am, 1 minute.
Yeah. Okay, those who finished can take this question. This is the next question. Please write down.
Ma'am, after this done. I'm done, ma'am. Done, ma'am.
Yeah, okay. Yeah, this is the next question, children. What is the least number by which 2541 is to be divided to make it a perfect square? So which means 2541 is not a perfect square. 2541, 2541 is not a perfect square. So by what number, by what smallest number it should be divided so that the quotient is a perfect square? Repeat the same procedure. Work till here and let me know. Done?
Ma'am, no, ma'am. 1 minute, ma'am.
Okay. Taken the question, all of you?
Yes, ma'am. Yes, ma'am.
Okay.
Ma'am, the prime factors are 3, 7, 11, 11. 2 11s, 1 7. 3
Okay.
into 7 into 11 into 11, ma'am.
Ma'am, it should be divided by 21.
Okay. So 3 how many times?
847, 121, 121, 11, 11. 7, 121s are 847. 120. And then 11 11s are 11. And 11 ones are 11 ones are.
Okay. So 2541 is equal to 3 into 7 into 11 squared. So here we see that the primes 3 and 7 don't occur in pairs. So you should take it away. If you have to find the least number to be multiplied, you should include the factors. To find the least number by which it should be divided, you should remove the factors that don't occur in pairs. You must remove the factors that don't occur in pairs. So 3 into 7, 21. 3 into 7 is equal to 21. So 21. So 2541 is to be divided by 21 to make it a perfect square. To make it a perfect square, you can check to make it a perfect square. Check. Divide 2541 by 21. 4 comes down. 2s are 42. 2, 1 comes down. 21 ones are 21, 0. So when you divide
Yes, ma'am.
2541 by 21, you get 121, and you know that 121 is a perfect square. The question is, what is the smallest number by which it should be divided so that the resultant number, the quotient, is a perfect square? So if you divide 2541 by 21, the quotient is 121, and 121 is a perfect square.
11. Yes, ma'am. 11. Okay, ma'am.
So to answer these questions, what is the least number to be multiplied or divided? You should find the prime factorization of the given number, express it like this, and identify the factors that don't occur in pairs. Identify the factors that don't occur in pairs. The procedure is the same for multiplication and division. So here 3 into 7. So the primes 3 and 7, they don't occur in pairs. So 3 into 7, 21. So 2541 is to be divided by 21. That's the answer.
Yes, ma'am. Yes, ma'am. Finish.
Yeah, write down all of you.
Done, ma'am. Done, ma'am. Eh.
Done, ma'am.
Done,
All
ma'am.
right, children. Yeah, those who have not finished, please complete and then leave the meeting. So that's it for today's session, children. Thank you so much. You may leave the call. Good night. Complete. Yeah, complete your work and then you can leave the call. Thank you. Good night.
Thank you, ma'am.
Thank you, ma'am.
Good night, ma'am.